Okay, Exponent Notes Day 1. In this video, we're going to review all of the rules that you've learned about exponents. I want to start first with a little bit of terminology. When you're working with exponents, whatever is being taken to the power, that's called your base. So here our x is the base. And then of course we have the exponent up here. And then any number that you have in front of the base, that number is called a coefficient. As you're watching this video, you may want to pause it so you can write down the notes at your own pace, however you want to do that. Okay, the first rule that we're going to talk about is multiplying. When you have x to the a times x to the b. When your bases are the same, both of our bases are an x, you can add the exponents. So that would give you x to the a plus b. In our example, we're going to do one where our variables, our bases, also have coefficients. And so we're going to first multiply those coefficients. So 3 times 2 is 6. And then we can do our x to the 4th times x to the 8th. So that would be x to the 4 plus 8, which is going to be 6x to the 12th. This middle step you don't have to write down. I just wanted you to see kind of the process of what we were doing. It might be good to write it down in your notes, and then you could skip that step on the homework. In our second example, we have x to the negative 5th times 4x to the 7th. If your base doesn't have a coefficient, you might want to write in a 1 there for your coefficient. So you know we're doing 1 times 4 is 4, and then x to the negative 5th times x to the 7th. So x to the negative 5 plus 7, and that gives us 4x squared. We're going to talk further down about what else we can do with negative exponents, but in an example like this, it's best to go ahead and add the exponents first, and then if the result is negative, we can deal with that in the following step. Okay, this next rule is what we call a power to a power, because you have something with an exponent being taken to another exponent, and that's when we want to multiply those exponents together. So here we have 3x to the 4th squared. Because we have a coefficient, we want to remember that that number also gets squared. So this is going to be 3 squared times x to the 4th times 2. We're going to multiply these exponents, but don't forget to also square the 3. So that's going to give us 9x to the 8th. In our second example, we have 2x to the 5th to the 3rd. So we're going to take our 2 to the 3rd power, and then our x to the 5th is going to be times 3. 2 to the 3rd is going to be 2 times 2 times 2, which is 8, so 8x to the 15th. As long as this number is a reasonable thing to calculate, like 2 to the 3rd is 8, that's relatively easy for us to do, we're going to go ahead and calculate that. If it's something like 15 to the 8th and it's going to be an enormous number, then we would just leave it 15 to the 8th. Okay, the next rule is dividing. When we have x to the a divided by x to the b, as long as the bases are the same, our rule is going to be to subtract the exponents. Now in this first example, you see we have coefficients again. When you have coefficients, you simplify them just like a normal fraction. So if we think about 12/8 as a fraction, we know that they're both divisible by 4, so we can simplify that fraction to be 3 over 2. So that's what we're going to do with the coefficients. That's going to be 3 over 2. And then, let me erase this. Then we need to do x to the 5th divided by x squared is going to be x to the 5 minus 2, which is x to the 3rd. So this is going to be 3x to the 3rd over 2. We want to write it as one whole fraction instead of leaving it as two separate, like 3/2 times x to the 3rd. It's better if we just write it as one fraction. In the second example, 20 over 15, those are both divisible by 5, so we get 4 over 3. Then we have x squared and x to the 8th, so we're going to do x to the 2 minus 8, which is x to the negative 6. And we'll talk about this again in a minute about negative exponents, but remember that if your result is a negative, your variable is going to need to go on the denominator, so this is going to be 3x to the positive 6. One of the things I like to talk about when we're looking at these is, for both of your fractions, look at where your exponent is larger. Here, your larger exponent is on the top, so your final result is also on the top. For the second one, your larger exponent is on the denominator, and so your variable results on the denominator. Anything to the power of 0 is 1. So x to the 0 equals 1. In this example, I want you to see that, remember that this means 2 times x to the 0. Okay? Exponents are only affecting what they directly touch. So the only thing that's being taken to the 0 power here is the x. Let me fix this. So this means 2 times, well, x to the 0 is 1, so 2 times 1 is just 2. Lots of times we forget that the 2 isn't included and people will write the whole thing as 1. Try to remember it's only affecting what it touches, and I think highlighting what's being taken to the power is helpful. In the second example, since the 0 is on the outside of the parentheses, this whole thing is being taken to the 0 power, so that's when the final result is just 1. Okay, negative exponents. If you have a negative exponent on the top, it gets moved to the denominator and it becomes positive. If your negative exponent is on the bottom, it gets moved to the top and it becomes positive. In this first example, we have 2x to the negative 3. Again, remember that the exponent only affects what it touches. So the only thing being taken to a negative power here is the x. So the x to the negative 3, that needs to move, but the 2, it stays on top. If you want to write it as a fraction first so you can kind of see top, bottom, that works too. So the 2 is going to stay put, and the x to the negative 3rd, it moves to the denominator. And when it moves, that's when its exponent becomes positive. In the second example, our negative exponent is in the denominator, so it needs to move to the numerator. The 2 will stay put because it doesn't have a negative exponent. So 2x to the 3rd over 1. And since that's over 1, we can just leave it 2x to the 3rd. And then in our last example here, we have x to the negative 2 over x to the 5th. If we want to subtract them, we could start by subtracting them, or we could say this one is negative, so it needs to move. So it's going to become 1 over x to the 5th times x squared. And when we move it, again, it becomes positive. Now we have the rule that we started with, where we're multiplying x to the 5th times x squared. And that's going to be x to the 7th. Now that we've talked about those negative exponents, if we want to revisit the example we did up here, with 20x squared for 15x to the 8th, you can see because we had, it was 4x to the negative 6 over 3, we needed to move that x to the negative 6 to the denominator. The 4 stayed put. So 4 over 3x to the 6th. All right, that's it.